Hello friends, today's video is somewhat a special one because today we are going to learn bitwise operator in Python. At first, this operator may look confusing to you, but I promise you one thing, if the binary concept becomes clear to you, bitwise operator will feel very easy to solve and do the operations. So first, we will understand the binary concept in detail and depth. Then, step by step, we will see each operator in practical way and try to solve them in easy way. So let's right now first see binary number system. To understand bitwise operator, first we need to understand the binary number system. Computer do not understand the decimal numbers. They only understand 0 and 1. That is why every number is converted into the binary. For example, the decimal number 5 becomes 101 in binary and the decimal number 3 becomes 01011 in binary. Each box represents one bit and each bit can have a value of either 1 or 0 as I have shown on the screen as well. Now this is where bitwise operator comes into the pictures. Now let's see what are the bitwise operator exactly and how they works. Bitwise operator works directly on the bits of a number. They do not work on the whole decimal number. They check each bit individually and perform the operation bit by bit on the given number. Let's right now see the types of bitwise operators. The first type is named as bitwise AND operator. Its symbol is denoted by using the ampersand sign. The rule is very simple over here. Only if both bits are 1, then the result will be 1. If even one bit among those bits is 0, then the result will be 0. For the same, I have shown an example on the screen as well. For the detailed evaluation, I will explain in the later view. Let's right now see an practical example for the bitwise AND operator. I've already opened the PyCharm window over here and create a file name with the bitwise.py. And I have put a comment over here as a bitwise AND operator we are going to perform. So and the binary operation as well, as this bitwise AND operator we know that works on the binary. So I put the evaluation for the binary table over here as well. Let me write a small code of snippet over here and step by step, then after I will explain each of the line in detail. I'm using a variable a, putting as a value, like assigning a value as in 5 over here. Then I'm using the b variable and assigning the value as in 3 over here. And as I want to print that on the terminal window as well, so I'm using the print function to evaluate them. After the evaluation, I want to print them. So basically, as we already know, we have some rules that we have to follow in bitwise AND operation. As we already know, if both bits are 1, then the result will be 1 in the binary operation. So like here, whatever the variables and the which I have defined over here that are in the decimal format. If I want to represent the binary operation, binary number or a binary number for the 5, then it will be like hash 101. And similarly, if I want to print the binary for the 3 as well, then it will be 011. Okay. Now let me just explain the evaluation over here. So as we already know, if both bits are 1, then the result will be 1. In binary AND operation, we check each bit by bit operation, and wherever we find both the values have the same bit, like a 1 and 1, then the result will be the 1 over here. Now over here, if I check the 5 binary and the 3 binary and check bit by bit, 1 0 is equals to 0, 0 1 equals to 0. Here I am getting 1 and 1. So when I calculate this AND operation between these two variable, then if I try to run the code, then I will get as an output as an 1 over here, because the last bit which I am checking here and here getting 1. So that's how the bitwise AND operator works in Python, doing the operation bit by bit. Let's right now talk about the another important type of bitwise operator, which is named as an bitwise OR operator. The bitwise OR operator is denoted by using the pipe symbol. The rule says if any one of the bit is 1, then the result becomes 1. For the same, I have shown a small code of snippet over the screen. I will explain them detailedly in the later view with a practical approach as well. Let's right now understand the another type of bitwise operator, that is the bitwise OR operator. I have already opened the PyCharm window and I have already put the comment over here and the binary table that we are going to use for the evaluation. Now let me just write a small code of snippet over here, and after that I will explain along with the code snippet how this binary evaluation exactly work in bitwise OR operator. So let me just put a equals to 5 and b equals to 3, somewhat the same value that we are already using. So I'm using this same representation over here. Let me just copy here instead of writing the new code. So let me just uncomment it right now, saving the code. Now I want to evaluate the expression as well. So as we already know, if we want to perform the bitwise OR operator, then we use this pipe symbol. So I'm using the print function and a piped, sorry, a pipe b. So before evaluating and showing the output, let me just explain the thing how the bitwise operator exactly works. So as like in the bitwise AND operation, we perform this type of binary evaluation operation for the bit by bit. Now, if I talk about the bitwise OR operator, here we have some different type of binary evaluation. If the both bits are 1, then the value will be 1. If one bit is 1 and another bit is 0, then the value also will be 1. Then another, like if bit is 0, another bit is 1, then the result also will be 1. But if both bit are 0, then and then at that only we get a 0 in the output, as in 0 result over here for the both bit if they are 0. So similarly, as we already know that we are taking this as value as a decimal, and we converted that behind us in the binary representation. So if we evaluate from this table of evaluation of binary, then let's check how what the value will get calculate. So 1 0, like 1 0 will be 1 over here. 0 1 will be 1 also. Then the last 1 1 will be the also 1. So in short, we get triple 1 in output as a binary. So if you check for the triple 1 as a binary, it will be the 7 number in decimal. So if I save the code and try to evaluate the value, so we get a 7 as an output. So that's how the bitwise OR operator exactly works in Python on the base of this binary evaluation table bit by bit. Let's right now see another important type of bitwise operator, that is bitwise XOR operator. The bitwise XOR operator is a special type of operator in Python to operate with the bits. If the bits are different, then the result is always 1. If the bits are same, then the result will be always as 0. For the same, I have shown an small code of snippet over the screen. For the detailed evaluation for the same, I will explain them in a later view with a practical example or approach as well. Let's right now talk about the bitwise third operator, that is bitwise XOR operator. So I have already opened the PyCharm window and put in already the comment over here for the evaluation that we are going to use in the bitwise XOR operator. So let me just write a small code of snippet, and after that I will explain how this table is get worked in the code snippet. So basically I need to define a variable a as in like 5, and another variable will be b, that as in like I want to assign as in 3 value. And similarly, I want also print the binary representation for 5 is like 101, and like for 3 it will be like 011. Now I want to evaluate the bitwise XOR operator between A and B. So for that I can use the print function and A XOR B. So just a sec. For the using of bitwise XOR operator, we use the upward arrow sign. Like this, I have defined in the print function. So before executing the code, let me just explain the things, how the things are happening in the bitwise XOR operator. So if I check this binary table, want to read it for you, and then I will explain the things how it exactly work with the code snippet over here. So if we check 1 XOR 1 equal to 0, 1 XOR 0 is equal to 1, 0 XOR 1 equal to 1, 0 XOR equal to 0 equals to 0. In short, I want to explain in some simple terms. If the both beats are same in the two different values, then the result will be 0. If both beats are different, then the result will be 1. If so, in short, if both beats are similar, then the result will be 0. If both beats are different, then the result will be 1. So if I talk about the current code snippet over here, as we have already represented in the decimal form, and behind the scene, if you are performing this XOR operation, it converted into the binary. So let's just evaluate right now one by one and see what the result will get generated. So if I go bit by bit, 1 0 comes to 1, 0 1 comes to 1, 1 1 if I talk it is comes to 0. So if I talk 110 in binary, which is somewhat similar to the decimal number in 6. So if I save the code and try to execute it right now, I get a 6 as a result. So this how the bitwise XOR operator works in Python using this upward arrow and beat by beat. Let's right now talk about the another important type of bitwise operator that is named as bitwise NOT operator. The bitwise NOT operator flips every bit. It converts zeros to 1 and ones to 0. The result can be negative because here Python uses the two's complement approach to evaluate the expression. For the same, I have shown a small code of snippet over the screen to demonstrate it. In the later view, I will explain that code of snippet in detail by an practical approach as well. Let's just right now talk about the bitwise NOT operator. So I have already opened the PyCharm window and put the comment over here as well. And if I want to use the bitwise NOT operator in the Python code, then I need to use this sign. This sign is called as a tilt sign over here. So let me just write a small code of snippet over here. Then I will explain the things, how this NOT operator exactly works. I'm using the x variable, defining a value with 5, and then I want to print that x variable in the terminal window as well. So I'm using the print function along with the tilt of x, like not of x. So like let me just try to explain what this tilt of x exactly in the Python understand. Like minus in brackets x plus 1. So this is what the exact operation it perform by Python if we are putting tilt of x over here. So if I calculate as a mathematical operation for the 5, I will get a minus 6 as an output. So if I run the code, see, I get an minus 6 over here. So this how exactly the bitwise NOT operator exactly works in Python. Let's right now talk about the last type of bitwise operator, that is left shift operator and right shift operator. We'll discuss first about the left shift operator. The left shift means moving beats to the left side. Each left shift means multiplying the number by 2. Now let's talk about the right shift operator. The right shift means moving the bits to the right side of the expression. Here it is similar to that we are doing the dividing the number by 2. For the same, I have shown a small code of snippet over the screen. For the detailed evaluation, I will explain them in a later view by a practical approach as well. Now let's see the last type of bitwise operator, which is named as the left shift operator and the right shift operator. So we'll see both of these operators in very simple and practical approach as well. So think of a number not as a value, but as a binary bit. that can move either left side or a right side in the position. The left shift operator, which is denoted by using these backward left arrows, and the right shift arrow is denoted by using the forward arrows, specifically this sign. Okay, the left shift operator means we are moving all the bits to the left side of the specific number or a direction. In the right shift operator, we are moving all the bits in the right side direction of the specific number. Now, I will take a small example over here and explain you in detail what exactly and how this the operator exactly works. So I'm taking a number over here that is an x equals to 5. Okay. Now I want to evaluate the first left shift operator on this specific variable. So I want to print the output on the screen as well. So I'm going to use a print function over here, like print and performing the left shift operation on this specific number. X left shift operator, and I want to shift it by 1. Let's just bear with me. I will explain the expression how it exactly evaluated. So see, as we already know, when we are using the bitwise operation, then we need to convert the specific decimal number to the binary conversion. So as an example, or I take here as an 5 value. So I already know for the 5, the binary representation will be 101. Okay, this is the binary representation for the number 5. Okay, now for the x value is 5 over here. In this expression where I'm printing this evaluation, I'm doing the left shift operator by 1. What exactly it means by 1? Actually, I am shifting the number bit by bit by 1. Exactly, if I talk about the left shift operator, if we are shifting to the left side by 1, then the number is multiplied by 2. Similarly, if we shift the number by 2, then the number is multiplied by 4, and so on till the 2 to the power of n. So if I evaluate it by using the left shift operator, then the output will be from 101, it will get evaluated to 1010 in binary. And if I talk about this binary conversion, this specific conversion, this value which is get converted after the bitwise left shift operator, it will be in the binary, but when we convert it to the decimal, then it will be the 10 in the result. So if I save the code right now and try to execute the value, so see, we get as an result as an 10 over here. For the similar expression, I will add the multiply by, sorry, not multiply, shift by 2. We'll perform this operation like this. Like earlier, I'm doing the left shift by 1. Now this time, I want to perform left shift by 2. So if I save the code again and then try to run it, so see, first time I get a 10 value, then I get a 20 value. Why? Because if I talk about the left shift operator, it is multiplied by 2. So 2 fives are 10, and then again if I shifting by 2, then it is multiplied by 4 over here. So it incremented on the side of 2's to the power every time when we do the left shift operation. So this is how the left shift operator exactly works in Python. Now let's talk about the right shift operator. I will take another example. Before that, let me just comment out this code right now here. Okay, and just want to clear the terminal to get it like not the confusion over the code while execution. So I'm taking another variable to explain the right shift operator right now. So I'm taking an variable which is named as an a, as in value like 5, somewhat similar. I will take it. And also I want to show a binary representation for this, and as we are doing the bitwise operations over the Python, so we need to get it evaluated for the understanding how this exactly works in the beat by beat manner. So as we already know, for the 5, the binary representation will be 101. And I want to evaluate a right shift operator. So I'm going to print the using the print function and evaluate by this expression. Okay. So let me explain you right now before executing the code. Like we know when we are doing the left shift operation, we know if we shift by 1, then it is multiplied by 2. If we shift by 2, it is multiplied by 4. But in the right shift operator, the beats will get in the removing manner, like in the deleting manner specifically. What exactly I mean to say in the deleting manner means like it will perform a divide operation over here. Like if I perform the A right shift operator by 1, shift by 1 means it exactly performing a dividation by 1 over here. Like specifically, if I evaluate it and save the code and execute it, see the output will be 2 over here. Why exactly 2? Because when we perform the right shift operation, it will get divided by 2 and then the evaluation will get calculated, and that's why we get as an output 2 over here. So, sorry. Basically, when we perform a right shift operator, then we get a divide operation over the shiftings. Like if I use shift by 1, then it is dividing by 2. Similarly, if I want to shift by 2, then it is dividing by 4 over here. So if I save the code and execute the value, see I get 2 then and then 1. If I evaluated the expression in the right shift operator, I just need to put a comment. Will show what exactly for a clarification to you that it perform divide operation. And over here, if I copy the same command and in this left shift operator, it perform multiplication. On every shift, it is incremented the value of the shifting and multiplied that number by specific thing or a value in left shift operator. If we talk about the right shift operator, then the value will be get divided for the specific number on the base of their shift. So this how exactly the bitwise left shift and right shift operator works in Python. So friends, today we learn more in depth in detail about Python bitwise operator. In the practical approaches as well, we solved multiple type of problems. In the next video, we will be learning more about the operator precedence and operator expressions as well in detail. If you found this helpful, like the video, subscribe to the channel and press the bell icon. Stay tuned for more Python tutorial. See you in the next video.